Hi, I'm Cassandra Snelling, Marketing Manager of Global Sustainability, and I want to welcome you to See You in Another Life, Unraveling the Complexities of LCA, brought to you by Sunoco. Founded in 1899, Sunoco is a global provider of consumer, industrial, healthcare, and protective packaging with annualized net sales of approximately $5.5 billion. The company has approximately 19,000 employees working in more than 300 operations in 34 countries, serving some of the world's best-known brands in some 85 nations. Sunoco is committed to creating sustainable products, services, and programs for our customers, employees, and communities that support our corporate purpose of better packaging, better life. The company was listed as one of Fortune's World's Most Admired Companies for 2021, as well as Barron's 100 Most Sustainable Companies for the fourth consecutive year. Sustainability at Sunoco is a top priority across all our segments and markets. It's why we're here. We have made some substantial improvements since 2009 in the reduction of greenhouse gas emissions, direction emissions from our operations, and the reduction of water usage. We also have 86% equivalent by weight of recycled packaging that we produce currently and 100% uncoated recycled paperboard with 85% post-consumer fiber. And now I would like to introduce you to Liz Ernst, who's going to unravel the complexities of LCA.
Thank you so much, Cassandra, for that introduction. So as Cassandra said, my name is Liz Ernst, and I'm a sustainability analyst at Sunoco, part of a broader global sustainability team that supports the entire organization. And I've been doing life cycle assessment and learning about it since 2018. So I'm going to go ahead and click through. To the next slide, thank you. Okay, so here's our roadmap for the presentation. I'm going to tell you a little bit about the history of life cycle assessment and where life cycle thinking comes from. What is it, first of all, and how we use it in industry. We'll go through the steps of life cycle assessment and its process, and go through an example of one carbon footprint of a kilogram of GPPS, a general purpose polystyrene. And the goal of this presentation will be to basically develop your understanding of life cycle thinking and theory so that you have a critical eye with which to view results when you see life cycle assessment results at your company or externally. Okay, great. So the history of life cycle thinking. I titled it Necessity Drives Innovation, and that's because life cycle assessment thinking comes out of the 70s, where we had mass inflation, we had an oil crisis, bottlenecks in the energy supply. Sounds a little bit too familiar right now, but so we had rising waste problems as well. And so we had this text published by the Club of Rome in 1972. It wasn't the first text about sustainability, but it was really the first one that garnered global attention. And their thesis was that the Earth's resources cannot support the current rate of economic growth. And regardless of whether their predictions were correct, it led to sort of the development in the 1970s of resource environmental profile analysis, which was kind of like the grandfather of life cycle assessment, and brought us into the 90s, where we had the Society of Environmental Toxicology and Chemistry hosting workshops on a technical framework for life cycle assessment, which led to the development of the standards that govern life cycle assessment now, that we'll go over later in this presentation in the early 2000s and late 90s.
So we just received a message, sorry to interrupt. It sounds like the slides might not be showing right now. So just to make sure that everyone can see those, can we go ahead and reshare our screen?
Okay. All clear here. It doesn't look like it's a centralized issue.
Okay. Perfect. Thanks, everyone. Thanks, Liz.
Yeah. So what is life cycle assessment? Great question. So life cycle assessment is the compilation and evaluation of the inputs and outputs and potential environmental impacts of a system throughout its life cycle. What does that mean? Well, we're tracking the physical chain formed by material flow throughout a product system. And our goal is to define the environmental impacts of an entire product system, identify the hotspots and what the most significant environmental impacts are. For example, if I was looking at a cradle to grave assessment of a product, so start to finish, beginning of life to disposal, I would want to know what phase in that life cycle has the highest environmental impacts. And what processes within that system are causing the most environmental impact as well. And that way you can target environmental reduction. So what does that look like from a system perspective? So this is an example of the life cycle of a plastic product. And let me see if I don't have my laser pointer because I don't think I have control of the screen, but here you'll see the system boundary. And that basically denotes the delineation between the system you're studying and the rest of the environment. And so a good example of that would be to say, when you're doing a life cycle assessment or carbon footprint, what you're doing is you're taking a real world system that's occurring and you're basically cutting it out like a coupon. And you can't do that in isolation. So you always have to delineate a system boundary between the environment and the system you're studying. And so once we've done that and we list everything from, raw material extraction to our production and conversion processes and use, as well as end of life, we want to know what are the resources we're taking from the environment, which you'll see listed as energy, water, fuel, and what are our impacts on the lower side of the screen to the environment. So really, we're creating a picture of all of the processes in our production system and the resources they take from the environment and the impacts they make on the environment. And LCA is a great tool for this because it's stakeholder neutral. So you really avoid burden shifting upstream or downstream. It's not from the perspective of the producer. It's not from the perspective of the raw material extractor. It's a neutral perspective across the system chain. So how can we use life cycle assessment? As I mentioned previously, we can do environmental hotspot identification. We can compare alternatives and benchmarking for R&D and design processes in your organization. We can assess impacts not only of products, but also processes, services, policies, or activities, depending on how you design your study. We can improve design and development, as well as evaluating effects of our decisions. So if you choose PET or metallicized PET as a liner compared to aluminum, what are your environmental impacts going to be? Life cycle assessment is also used in labeling schemes like the Carbon Trust or environmental product declarations. And also Scope 3 impact determination closely follows life cycle assessment, although it's a little different. So some important terminology to go through. We've discussed life cycle assessment, of course, but there are a few others that get thrown out around this in the same way in the industry. So you have carbon footprints, which is very similar to life cycle assessment, except you are zoomed in, you are locked onto carbon, and you want to know the sum total of your greenhouse gas emissions. Whereas life cycle assessment can tell you a bit broader things like water use, energy use, yes, also carbon, but not just carbon. Whereas a carbon footprint is focused on solely the greenhouse gas emissions from your product system. We also have environmental product declarations. And an EPD certifies that or an EPT certificate are declarations that quantitatively evaluate and declare environmental performance of a product or service. And that, if you are located in Europe, I'm sure you're intimately familiar with EPDs because I believe they are required in certain industries in the European Union. We also have scope emissions, which are greenhouse gases from corporate value chains. They are broken up into different categories. So you have your scope 1 emissions, which is emissions from your factories or locations from the direct combustion of fossil fuels. We have your scope 2 emissions, which are emissions associated with purchased heat or power. And scope 3, which is quite literally everything else. So that's employee travel, that's emissions associated with purchasing, emissions associated downstream with end of life, incorporated assets. It's very extensive and can get quite complicated in tracking. I know Sunoco has a dedicated team that handles this because it's bigger than one person. So on the right, you will see the different standards that sort of govern each of them. Life cycle assessment is governed by the International Standards Organization. There are two. There will be a test after this, so please pay attention. You have ISO 14040 and ISO 14044. They are the principles and framework and requirements and guidelines. You also have an ILCD handbook that's pretty great, although that's not necessarily a standard. It's more of a best practice document. Carbon footprint also has its own ISO standard. EPDs are governed by the EN 15804 in the European Union. And EPDs are unique because they actually have their own product category rules. So packaging has one, for instance, and it governs best practices of doing an environmental product declaration for your products. They have ones for bakery items and initial life of plastics. It's very detailed. And then we have the scope emissions, which are governed by the GHG protocol. I'm not going to go too in depth into scope emissions. That could be a subject of an entirely different webinar. So examples of what you can measure with life cycle assessment. And as I've already said, of course, over here on the left, you'll see carbon footprints. That's a small piece of life cycle assessment. You can also measure energy use, water use, land use change, which is, if you plowed a field to harvest a product, you'd impact that land's ability to store carbon in some form. So you can measure that. You can also measure things like eutrophication, which is just a fancy word for if you've been driving down the street and you see this pond and it has all this green algae on top. Eutrophication happens when you have leaching of nutrients like nitrogen into our soils, which the algae loves, and it grows like crazy on top of the water, but it deoxygenates the water below and it can kill plant life and fish. So not great for eutrophication. We can also measure things like acids and ecotoxicity. There are over 3,000 chemicals included in ecotoxicity, so it can get pretty in-depth. So what are the steps for life cycle assessments? First, like with any project you would start, you need a goal and scope. So the goal and scope sort of denotes the purpose of your life cycle assessment, who its intended audience is. Are you making a comparative statement? Because that means you need a third-party assessment and that needs to be declared in the scope. It will tell you your functional unit, and that just means when you get your results, what is it tied to? Is it 1 kilogram of PET? Is it one pallet? Is it one croissant? Whatever you decide to measure is your functional unit. We'll talk a little bit about that later, and your reference flows. And then once we know our system, we've mapped it out, we've clipped out our coupon from the real world, then we need to build a life cycle inventory. And that's just a tabular listing of all the resources taken from the environment and all the resources emitted to the environment. It's quite extensive. It's usually broken up by emissions to air or water, or resources taken from the air or the water or land. And once we have that, we need to do something with it, because it's not enough to know well, I mean, you have things that you have certain studies that will stop at the inventory. But if we really want to know more, if we want to categorize our emissions into these little buckets here, we need to understand, how much greenhouse gases were emitted, not just how much carbon, how much methane, and how much nitrous oxide, but we need to categorize that in terms of an impacts category. And that's what we do in the impacts assessment, which will be more clear once we walk through our example. And in the final stage, we need to do a completeness check to make sure that all the life cycle stages are accounted for equally. So you're not comparing unlike things or unlike systems. We would do a sensitivity check. As you can probably assume, there are a lot of assumptions made in life cycle assessment because you're taking a system out of the real world and implementing it into a model. So you can run a sensitivity check on any of the assumptions you've made and a consistency check for data. So we would do that. There's also optional steps, which we'll go through in our example. Really quickly, I just want to throw this in there before we talk about a carbon footprint, because I'm sure, like myself, you're seeing a lot of companies making commitments around their scope emissions or their GHG emissions, reducing their carbon impacts or going net zero. And what that all means is talking about global warming and greenhouse gases. So we measure them, and what you're measuring when you're measuring the impacts of greenhouse gases is called infrared radiative forcing. Very simply, indulge me in this, the Earth's atmosphere is the hat, okay? So essentially when you emit, so anthropogenic or human-induced climate change gases, so emitting GHGs, which are carbon dioxide, methane, nitrous oxide, fluorinated gases, there's a lot of different ones, but those are the main ones. So when we emit them, we're making the hat denser. And you can't see it with arrows, but not all the energy that the Earth absorbs from the sun is kept in the Earth. A lot of it is radiated back out into space. But the heavier our hat is, or the denser the atmosphere with greenhouse gases, it makes it harder for that heat to escape. And that's why we're concerned with global warming and greenhouse gases. The trick is not all of these gases have the same blanket effect. So you'll see a lot of companies, if you look at a carbon footprint study, it's always going to be in terms of carbon or carbon equivalent. And what that's saying is that's taking gases like methane or nitrous oxides, and that's scaling it to the same infrared radiative forcing or blanket producing effect that carbon has. And each gas will do that a little bit differently. Methane is either 25 or 28 times more impactful than carbon, depending on who you're talking to. Nitrous oxides are over 200 times worse. I believe it's 268 or 265. We'll see that on the next screen. And so fluorinated gases sometimes in the thousands. So it depends. And that's why, everyone's sort of making goals around carbon, and we're concerned about carbon. I will say though, the Earth does look very cute in that hat. So anyway, so for the carbon footprinting example, we're going to do a cradle to gate. That means we're going from the beginning of life to the end of factory production for resin flake for 1 kilogram of general purpose polystyrene. And so we're just going to go through our example. We're going to go through the steps that we talked about. So we're going to start with our goal and scope. And so on the left column, you'll see things that need to be included. This is not an exhaustive list. It's just what I could fit on a PowerPoint screen, but I think it'll give you a good example. So we need to denote our intended application, which I said is educational to illustrate the process of life cycle assessment. Who our intended audience is, that's all of you. And are we making any comparative assertions? That's really important. And I said no, because we're not. So I mentioned a functional unit earlier, and basically it defines the system quantitatively in terms of its function. So a good example of this, plastic really isn't, because I'm going to say our functional unit is 1 kilogram of general purpose polystyrene resin. But a good example would be a pallet. We're all familiar with them. They carry things around the world. They're involved in all supply chain echelons from here to Brazil or to Turkey. And so basically, you could evaluate one pallet compared to one pallet. You could evaluate it in terms of the function of a pallet, which is to carry something. So you can evaluate it. The functional unit could be however many pallets it takes to carry 1,000,000 pounds of material. You could evaluate it. The process of a pallet is to go trips through the supply chain. So you could evaluate it in terms of trips through a supply chain. So it's not just one mug compared to one mug. The function of this mug is to hold a beverage or liquid. So you could say, I don't just want to compare the mug, I want to compare volume. So it's important that the function be included in that, because above all else, we need to make sure we're comparing apples to apples, because it's not fair if it's not. So after we figure out what our functional unit is, which for our purposes is 1 kilogram of GPPS, we would build our system, which you'll see on the next slide, and choose our impact categories. So I have GWP, that means global warming potential. That's our carbon footprint, and it's measured in terms of the potential it has to impact global warming. And we're using the International Panel of Climate Change's model for that, and it's measured for 100 years. And that's something to pay attention to. Some people will measure it to 20 years, and some gases like methane leave the atmosphere around 20 years after they're emitted. So there's a big difference sometimes, depending on the system, if you measure for 20 years or if you measure it for 100 years. If your system that you're measuring emits a lot of methane and you measure it for 100 years, it's going to not necessarily be a great comparison. You would want to scale that to 20 years depending on your goals for your assessment. So you'd also include any assumptions that you make and any data quality requirements that you have for your study. So that being said, we're going to build our system map, and you don't have to do this. This is an optional step, but a lot of people do, just because it's a great way to visualize what you're trying to achieve. And so this is a cradle to gate build for general purpose polystyrene, and you'll see the different color flows. So gold here is an energy flow. We're taking energy from the surrounding environment. Green would be an environmental flow. So crude oil would be an environmental flow along with natural gas. And then the black here is a waste flow. So that's the emissions, or excuse me, it could be waste or emissions. So these are emissions emitted to the environment from each process. And so the blue here is just mapping our product flow throughout the system. So we have everything from crude oil production and natural gas production, petroleum refining, producing benzene, olefins, into our general purpose polystyrene resin. So once we have a good handle on that, we can take each of these blue boxes, they're called unit processes, and then build our inventory for each of them. We're not going to do that because that would take a very long time, and I don't want to keep you on here longer than an hour. So we're going to walk through an example of what that would look like. So we would have, in our carbon footprinting example, we'd have resources, Okay, so we'd list our resources from the environment. So we'd have about 1 kilogram of crude oil and 0.895 cubic meters of natural gas. And then importantly, we would list our emissions to the air, what was leaving our system into the environment. And remember, we're just looking at greenhouse gases. So here are your heavy hitters. So we have carbon dioxide from fossil fuels. We have methane and carbon, that actually should say nitrous oxides, my apologies. So this here to the left with your emissions to air, carbon dioxide, methane, nitrous oxides is what we have for our scale. And like I said, methane and nitrous oxides don't build the hat or like insulate the Earth's atmosphere the same way carbon dioxide does. So we need, if our goal is to get everything into a carbon equivalent, then we need to scale it to carbon. And so methane is about 20 times better at trapping heat in the atmosphere than carbon. Nitrous oxides, 265 times. So we would take our output and we would multiply straight across. Carbon to carbon is a 1-to-1 exchange. Methane to carbon is 28, so we multiply by 28, and nitrous oxides we multiply by 265. And at the bottom, you'll see the total of 3.67 kilograms CO2 equivalent. That's our carbon footprint of a cradle to grave system. So now that we have our result, what do we do with it? Well, I mean, we could put it as to the left on a graph, with our kilogram CO2 equivalent for 1 kilogram of GPS and our climate change impacts. But we can also do more things with it. So as I said, there are the 3 mandatory steps. We'd have to review our completeness. We'd have to look at sensitivity as well as consistency. And then we could do some fun things that are optional. So one of them is normalization. So we could normalize this across a per capita emission for the United States, if you wanted to. You could normalize it against other products in your industry or industry averages to see what the relative impacts are. That these are all optional steps because they involve a value judgment that's not necessarily scientific. So yes, it would be scientific to divide it per capita, but I'm also making the choice to do that for a normalization. So that's why they're optional and not mandatory in all of LCA assessments or carbon footprint assessments. If we had multiple impact categories, so if we were measuring something in addition to carbon, if we were measuring energy use or land use impacts, we could weight the results. So that would mean we're saying carbon is more important. We're going to give it a higher weight than energy use or land use. Again, that involves a value judgment. And weighting can be useful for your organization if you have specific priorities. Like if you're really trying to reduce your carbon impacts, you can weight carbon as a higher if you wanted to reduce your impact to a single eco score or environmental score. And there are methods of doing that. And it allows people to sort of get significance from that weighting to show results that are better for you, or not the results would be better, but your priorities would be reflected in the weighting of those results. And grouping would just be grouping like impacts. So if I wanted to split this up and I had multiple instances of transportation across the value chain of my product, then I could just group all of transport together and look at that if I wanted to. So you would group like impacts. Anyone who has seen Legally Blonde understands this reference. If you haven't, picture a California Valley girl saying, what, like it's hard? Like I just got into Harvard, it's fine. So why are carbon footprints and LCAs challenging? What to include within your system boundary is very challenging, or can be very challenging. Because it's not always cut and dry where your system ends. So a good example for that, and this will be relevant for the 4th bullet point as well. So say I had, I was thermoforming something, I was thermoforming a tray, and I had scrap coming out of the same unit process I have my product. So we have a unit process for thermoforming, and you have the product leaving our system, and you also have scrap. So do you include the scrap in your system, or do you leave it out? Do you just allocate a portion of the environmental impacts to the actual product? Or do you expand your system to include the waste treatment of that scrap? That's a choice. Both are correct. Although if you're following standards, it's better to expand your system and include the waste treatment than it is to allocate. That's an advanced topic for another day. But capturing real world processes accurately can also be very challenging for reasons I just said. We're reducing a system that is difficult to be delineated from the environment into a model. So that always involves value judgments and assumptions. So it can be very difficult to do that. Another issue is data accessibility. So if you have proprietary information, if you're trying to compare your products to a competitor's, you're not going to have access to their unless they're very generous, and likely would involve several NDAs, although I don't see this happening. But if you wanted to, have primary data, so that means data from your competitor into your model, it's proprietary. You're probably not going to get that. And so having quality data, especially in comparative LCAs, can be a big challenge. Again, I said, what if you have multiple products coming out of the same process? What if it's not waste? What if it's just a co-product? A cow is a fantastic example for this. So if you wanted to do a life cycle assessment on a kilogram of beef, it's very hard to separate the beef from the cow, because the cow has been reared on this farm. It's eaten grass. It has, had methane emissions from gastric fermentation in the cow's rumen, which is their stomach, and AKA cow burps. But the cow has multiple valuable co-products, milk, cheese, any kind of dairy products that's coming from a dairy cow, and leather, offal, which is the internal organs, bones, gelatin. A lot of different co-products are coming from one animal. And so building out an LCA where you just want the environmental impact of beef, very difficult. You'd either have to find some way to allocate those impacts based on mass or based on economic value. You could do it based off of energy inputs as well. It just depends. Usually mass is most preferable, but again, you're making value judgments saying, okay, well, we're just gonna, allocate this amount of environmental impact based off of mass. So that can be very challenging. And also LCAs, in their traditional sense, all of the life cycle assessment information we've been talking about in this presentation has been talking about a thing called attributional life cycle assessment. Not important, that word, but just know that there's a counterpart called consequential life cycle assessment that takes into marginal impacts and marginal utility along with economics. So that would be a non-static model that's always changing with market demand. But the traditional LCAs that you've likely seen or heard of or interacted with are attributional. So they're static models that are based on previous data. So they need to be updated. They might not be necessarily reflective of industry value. So that can be something that's challenging as well. So what questions should you be asking? I thought I'd just list out a few. If you're not an LCA practitioner, if you're just someone who touches those results in marketing or in some other fashion, it's important to know what questions you should be asking when you see life cycle assessment. So first off, what's the reference unit? What's the functional unit? What are we comparing? Make sure that when someone sells you, especially if it's a comparative LCA, that those things are like products. You can compare a liter PET bottle to a 16 ounce. I'm sorry, I don't know what that is. I think that's roughly 500 milliliters. To each other, they're both made of PET and they are both bottles, but do they necessarily fulfill the same function if one holds more water? So make sure that that functional unit would be scaled to the volume of water that neutralizes the fact that one is quite smaller than the other. So it's important to have a functional unit that represents the systems you're looking at accurately and in a way that can be compared. The second question, what are we measuring? Do we just want to understand our carbon footprint? Are there other metrics we want to be looking at, whether that's water use, energy use, eutrophication impacts, ecotoxicity? And that's important as well because everyone is very focused on carbon right now. But if you have ever looked at an LCA of plastics, you know that the consequences for landfilling a paper product that holds the same volume versus a plastic product that holds the same volume of each other. They say they both hold, 500 milliliters of liquid, and you throw them in a landfill. The paper product, which is conventionally thought of to be more sustainable, will emit more greenhouse gases under abiotic conditions as long as the they're called methanogens. They're little bacteria that eat the material and release carbon dioxide and methane. That will have a higher carbon footprint if you throw a paper container in a landfill versus a plastic one, because the plastic is relatively inert. So carbon, if you were looking at end of life, would not tell you the full picture. You need to include more impact categories to get a robust understanding of your system and its impacts. And what is your data quality level should be the third question you're asking. So Sunoco uses streamlined life cycle assessment. It's kind of, it's helpful when you're doing high volume of understanding your impacts. It's best for directionality, but it sometimes does not include primary data. So a lot of life cycle practitioners, you have something called the foreground and the background systems. So the foreground system would be the system that so if you're a packaging converter, the packaging conversion process is your foreground system, and anything occurring upstream or downstream of you is your background system. A lot of life cycle assessment practitioners will use industry average data for the background system, and then for the foreground system, they will try to use primary data. Secondary data is based off industry average. So if you have upstream suppliers that are innovating and have, processes that aren't reflected in industry average numbers, it's not going to really be a good example for your life cycle assessment. It's not going to most accurately capture the process that's happening. So that can be challenging. Another question is, do you have all the data you need? Is there any gaps in that understanding? And they should be documented if there are. And what was included and what was excluded? That's a big one. A lot of a great example, again, would be the pallets. So a lot of people, if it's packaging, will not include a use phase because most people are just opening the packaging, eating the food, or taking whatever product is contained in the packaging out of the box and throwing it away. So the use phase really doesn't include any environmental impact. A lot of people exclude it from the study. If you're a pallet, you're carrying a lot of material around the world all the time. So by nature, you are included with the fossil fuel combustion of the transport. So making sure that not only you're comparing like for like, but that you're also making sure that the steps in the system from cradle to grave or cradle to gate are all included equally. If you're excluding use, you would have to exclude it for your comparative product as well. If you're excluding filling, you'd have to exclude it for the comparative product as well. So those are kind of, I think, the 4 top questions. You don't have to know a ton about life cycle assessment to just make sure, what are we comparing? Is that fair? What are we measuring? Did we do it right? What was excluded? I think are the top things. So I realized as I was counting, that was 5 questions, but that was a bonus question. You're welcome. So I think I'll sort of close it with this example, and then I'll open it up for questions. I think there's a conclusion slide after this, but this is a great example illustrating what we've been talking about these past 40 minutes. So this is a carbon footprint, just like we did for our general purpose polystyrene. This is looking at different resins, PET on the left, in the center you have HDPE, on the right you have polypropylene. And we're looking at global warming potential in kilograms of CO2 equivalent. So they've made everything relevant to carbon, or related to carbon, reduced to carbon. Either way, it's all in terms of carbon, and it's per kilogram of resin. So that means if we're going to look at PET, and I'm sorry, I can't pull up my laser pointer, but we're going to look at the left of the screen that has all of the options for PET. So you'll see recycled PET cutoff. To the right, recycled PET, open loop, and virgin PET. The colors represent different, like flake to pellet energy, collecting and sorting. So those are different steps in the life cycle that they have analyzed. That's really not important. We're going to look at the totals of the bars. So if you see this, you'll see, okay, well, there are 3 carbon footprint values for PET. One is virgin. Okay, sure. I can understand why that was different from recycled PET. But why are there two carbon footprints for recycled PET, and which one is right? Would be a question I would have if I first saw this. So answer, they're both right. It just depends on how you drew your system. So very briefly, when we're talking about recycled content, we're talking about an exchange of material between the system that recycled it and the system that uses it as virgin content. And there are multiple schools of thinking on this. So one would be our first one, recycled PET cutoff. That's saying if I'm using PET in my system that's been recycled, it's got a clean slate. It is free and clear. It is not associated with virgin PET at all, because it's a new life and it was material that was recovered. So you didn't have any of the associated production impacts. You didn't need to extract fossil fuels or go through that whole process. So we're saying free and clear, you're good, you're divorced, you have no baggage. Okay. So the next school of thought would be, and that's so that would be mostly reflective. The first one, our recycled PET cutoff, that's free and clear. That would be mostly reflective of a recycling system where you throw something away at end of life and it re-enters the same cycle that created it. So that would be a closed loop recycling option. The next option that's in between virgin and PET cutoff is recycled PET open loop. And that open loop just means that when you have Mountain Dew bottle or a green PET bottle, for example, if you threw that in the trash and or in the garbage and it wound up in you recycled it. In America, we have single stream recycling systems. So it would go to a material recovery facility where it gets sorted out and it would, get repelletized and reused as recycled PET, ideally. So that being said, it's an open loop system because it's not entering the same processes that created it. And you'll see the blue impact is associated with all that is the entire impact from virgin PET. So you'll see on this one, you have basically half of the impacts from virgin PET. So this model is saying, yeah, it's recycled content, but it's not entering the same process that created it. So we're going to basically charge you half. So you get half of the burdens associated with virgin production, and the system that recycled it in the first place only gets half the burdens associated with the emissions for recycling. You also share a credit too. So it can get a little weird in terms of how you account for recycled content and recycling. But basically, you have a cutoff approach, which is the left, that's saying recycled content is not associated with any burdens from its previous life as virgin PET. You have a middle ground approach where it's like 50-50. We're going to charge you half because at some point you were recycled PET and there were associated burdens with producing that. And then you just have plain good old virgin PET. So that being said, both of these are correct. And all three of them are correct. That's from the American Chemistry Council. And that is why it's important to ask questions about how it was done. What is it included? You don't have to ask, well, was this a cutoff or was this an open loop system? But just having a generic, higher level understanding of what's going on in the system, because the system you build, the model you build, of course, impacts your results. So that being said, next, there we go. Come on, there. Okay, so in conclusion, LCA is extremely useful for evaluating products, systems, and policies. It can help you achieve your organizational goals, whether that is GHG reduction, scope reduction, measuring your environmental impacts in the different systems we talked about like EPG or scope 1, 2, and 3 counting. But it's only as good as the data you input into the system. So if you're putting bad data in, you're going to get bad results out. And modeling real world processes is complex and it's difficult to accurately capture, which is why it is very important to view results with a critical eye and know that even if you had you could isolate your system in a bubble, like a magic bubble that could actually, magic would make this possible. So it's not magic. If you could isolate your system in a bubble and count the, if you were doing a carbon footprint, count the greenhouse gas emissions, you still would not get 100% of an absolute value of the carbon impacts of your system. So these results, carbon footprints, life cycle assessment, EPD, do not provide absolute values. They provide relative values and can help you understand the directionality, but it's not saying 100% that every time you produce a kilogram of GPPS, it's going to be 3.67 kilograms of CO2 equivalent. It's depending on the model that built it. Even if you use industry averages and survey a ton of companies, those results are going to vary based off your equipment, what fuel you're combusting, what your energy grid looks like. It's very different from, say, Spain to the UK, Germany, the US. So that's important to understand. It's not helpful to just pick up a study that's looking at something you're interested in and compare it to another study that did it completely differently in a different country. It can give you an idea, but they're not absolute values and they can't just be generically compared to each other. And I will leave you with this. If you ever decide for your company, or if anyone decides, myself, to publish a comparative LCA, it definitely has to be done with a third-party review. It's governed in the standards. And for life cycle assessment, I think it's a great tool, and it can continue to be great through transparency and through observing the standards and publishing results that are real results. So that is all I have for life cycle assessment today. I'm really grateful for this opportunity to talk about it. As you can see, I love this. So it is time for Q&A.
Yeah, thanks, Liz. So we have a lot of questions. Let's start with, so on a previous slide, can you dive in a little bit deeper about how you converted the other gases to that CO2 baseline?
Yeah, that's a great question. Okay, so here, I'm so sorry, I wish I had a laser pointer. Let me see if I can put a little bit more effort into finding one. Nope. Okay, we're going to do this laser pointer less. So on the left, we see it from our inventory, we listed out our emissions to air. We have carbon dioxide, methane, and again, that should say nitrogen oxides here. So carbon, we want everything in terms of carbon because that has, it's like if you were doing algebra and you had 5x plus 3z plus 3y. You can't add them together. You need to get them all to a standardized unit, and that unit is CO2 equivalent. So we need to get our other greenhouse gases to a carbon equivalent, or that is to say, to the same impact carbon has on building the Earth's hat, on insulating the Earth. So methane, so carbon dioxide, you'll see the emission factors, that's what we're multiplying it by. The emission factors just say how much stronger impacts of trapping heat in the Earth's atmosphere is this gas than compared to carbon dioxide. So if we start with carbon dioxide, it's 2.710. If you if you want to get everything in terms of carbon equivalents and you're starting with carbon dioxide, that's a 1-to-1 exchange because it's already your unit you're looking for, you're great. Methane has 28 times more impact and ability to trap heat in the Earth's atmosphere than carbon. And these are determined by the IPCC, the International Panel of Climate Changes. Pretty much carbon, I will say, for the carbon footprinting, this global warming potential, which is the impact category we're looking at right now, carbon is the one where scientists agree the most on in terms of how it should be measured and what we're measuring. So it's good information. So for methane, we have 0.03 kilograms, multiply that by 28, and you have 0.848. Nitrous oxides, They hit about 265 times harder than carbon in terms of trapping heat in the Earth's atmosphere. So I would take my value from nitrous oxides emitted from our system and I would multiply that by 265. And then when you add all these up under the LCIA results column, you'll get your total of 3.67 kilograms of CO2 equivalent. Everything is normalized to carbon. I hope that answers your question.
Thanks, Liz. That's perfect. And then, so do you see brand owners focusing more on LCA to combat climate change versus just recyclability? So what are those trends that you've been seeing over the past few years?
So a lot of I will say in the packaging sector or just in industry in general, you do have a lot of people who are very focused on recyclability, who are very concerned with increasing our stockpile of recycled content because you can't have one without the other. But you also see a trend of companies who are making commitments. You'll see SBTI, it's the Science Based Target Initiative, and they're saying Amazon, they want to be net zero by, I believe it's either 2050 or 2045. And that just means, it doesn't mean that they're not emitting carbon anymore from their activities. It just means they're doing basically in life cycle assessment, when you do something like buy renewable energy, you can count it as a credit. So if I bought a kilowatt hour of wind power, I could say, well, I didn't take a kilogram of kilowatt hour of energy from the grid. So I could basically give myself a little discount, like I get a coupon. You didn't use these carbon emissions, so here's a coupon. And that's how you would get to net zero. You would have to do things that offset carbon. So you could plant trees. You'd have to plant a lot of trees, but you could do it. You can buy green energy. So I see a lot of companies making promises like this, going net zero, or having commitments around scope emissions, which are your greenhouse gas emissions from your value chain. So it's definitely coming up in popularity on both ends.
Perfect. And is it possible to compare data between two different LCA studies, and what are the potential issues?
Yeah, so you can compare data. That's great. Understand the data in context. So look at where it was generated, how it was generated, the time it was generated in, and you can look at data to sort of understand the nuances between the studies. It's just not great to look at results compared to results because the data might be differently. So you'll see a lot of studies that are meta-analysis of life cycle assessment. Like the other day I was looking at traditional fossil fuel-based plastics compared to plant-based plastics, PLA and PHA. And there was a meta-analysis of 44 LCAs. And they've done that. They've looked at the data and compared it. So great, compare the data, understand the differences between the studies, just don't blanketly compare the results.
Perfect. And has there been any discussion around including social impacts or equity impacts in the LCA analysis?
Yeah, so traditional life cycle assessment, as the term's used in the industry, it refers to environmental life cycle assessment. There's also SLCA, or social life cycle assessment, that incorporates, I touched on it a bit in my master's, but it incorporates things like labor standards and relies on stakeholder surveys to understand the value chain of social impacts. But there are standardized systems for that. I believe the tool is called Hotspot, and it is an SLCA tool where you can understand that. I know there are other surveys like EcoVadis, or I'm blanking on others, but there are a lot of other surveys you can report into that take account into social impacts as well. But yes, SLCA is a real thing.
Perfect. And then if you can't find a comparative LCA, how should you interpret two GWP impacts reported in two independent LCAs? And is that possible? And if not, how should you use the LCAs to help inform your decision making?
Yeah, absolutely. So if you just have two independent LCAs, like if you were just looking at, I don't know, the American Chemistry Council compared to someone else, and maybe Dow Jones commissioned a study, I don't know. So if you were just looking at LCA to LCA, you can compare them in the sense you can look at their scope, their data, what was included, what wasn't. And you can do that for both studies and then understand how they got their results and pick apart the nuances of the study. I just meant it's not great to just look at, okay, I have one result and one result, let's compare. More needs to be done. So how you would best use that information to help your company, I would say look at the study and how it was completed, and consult with experts in your company who might know that process. If you want to make sure that they modeled the system accurately, if one study was done in Europe and one was done in the US, look at the US, because that's going to reflect, and your company is in the US, that's going to reflect your energy grid likely. So you can compare them and you can use them. It's just important to understand the nuances behind the study, and consult experts if you need more information.
Perfect. And I know we're getting close to time, but we're going to try to knock out a few more questions here. We've got a lot of great questions. So in the last example, so Liz, going back to the charts where we see the recycled resin versus the virgin resin, shouldn't we have two footprint versions for virgin as well? One where it gets assigned the full burden and one where it only gets half, because the other half is assigned to the recycled product that we assume will be creative. And then how can we create it? And then how can we tell the difference?
Yeah, so that's a fantastic question. So yes, there should be, if this was a cradle to grave LCA. This is a cradle to gate LCA. And that just means that it stops at the factory gate. So it's looking at, for virgin, it's looking at fossil fuel extraction to the point of the PET resin being produced. If this were a cradle to grave LCA and the PET was recycled at end of life, then you're absolutely correct that it would have a discount. So it would also have a lower impact if this was cradle to grave and you included recycling as your end of life option. That question makes me happy. Someone got it. Okay, yes.
Awesome. And then can you compare the LCA for your own resin to industry averages for that resin type?
Yes, you can. You can absolutely do that. You can even, once you get your results for your internal study, you can normalize your data against industry averages. That is okay. I would say, if you're publishing a comparison, of course it would have to be third-party verified, but just lay it out in the scope. This is the comparison we made. This is how they calculated industry averages, and this is how we stack up. So a lot of that, it just needs to be transparent. So, explain what industry averages you're using and what was their geographical and temporal scope. But yes, you can definitely do that.
Perfect. And then can you explain the biogenic carbon and how it is applied to paper?
Yes, great question. Okay, so really quickly, trees sequester carbon throughout its life cycle. We know this, photosynthesis, it takes carbon dioxide out of the atmosphere and stores it in the tree. And so when you cut down the tree or you fell the tree to produce fiber products, there's embodied carbon in the tree, but also it's sequestered it from the atmosphere. So if you make paper out of the tree and the paper reaches its end of life and it's incinerated or it's left in a landfill, it reaches some kind of end of life. Let me back up. So there's carbon emissions emitted from the combustion of fossil fuels. That would be if you use like a skid steer excavator powered by fossil fuels to help you fell trees. And we count that as fossil-based carbon emissions in our life cycle assessment. There's also embodied carbon emissions in green products, or products that are from a biosource, like plants and shrubs and trees and soil and crops. So when we're looking at biogenic carbon emissions for products that have biomaterial in them, some LCA practitioners will ignore it because it sequestered carbon throughout its life and stored it. And then at its end of life, they calculate, okay, well, it will hypothetically release the same amount of carbon it stored. That's not always the case. Sometimes, especially if it produces methane in a landfill, it can emit more, it can emit less. And so you can actually do, if you really want to dig in the weeds, you can do calculations for carbon emissions and sequestrations to handle that. I will say most LCA practitioners, especially if you're doing streamlined life cycle assessment, will just say net zero. It takes energy, it takes carbon out of the air and it emits carbon at end of life. And that's that. We're saying it's not impactful and it'll cancel each other out.
Thanks, Liz. And then one more question. So is it possible to publish or disclose the results of an LCA without a critical review? And then regarding the review, there are single person reviews and then using a panel if comparisons are made. Can you discuss that a little more?
Yeah, so if we are following ISO standard and you are publishing a non-comparative LCA, then likely you do not need a third-party verification. However, if you're making a comparative life cycle assessment statement, then you do need a third-party verifier. And you're absolutely right. There are single verifiers and there are panel verification. Panel is obviously going to be the best in terms of quality of review. It's also the most expensive. So in the product environmental footprint standards, there are scores for the reviewer based off of how many years of experience in life cycle assessment they had, how many reviewers you had. So they have developed a matrices that will allow you to score the review and make sure that it was acceptable. I don't know if there's a cutoff for unacceptability. I just know that you can score it for acceptability. I can look into that, but yeah, third-party panel review, great if you want to pay for it. Single review, also acceptable as long as they have solid knowledge of life cycle assessment and the industry you're doing.
Perfect. Well, thank you so much, Liz. And thank you to all of our participants for hanging in there with us. I know we're after the hour and we have a lot more questions that we can answer. So thank you so much for your engagement and participation. If you have more questions, please do not hesitate to reach out to us at sunoco.sustainability@sunoco.com, and we'll make sure to get back to you as quickly as possible. And we hope to see you at our Q3 webinar. Thank you again and have a great day.
Thanks.